Hello students, today we have to find the forces in this member and in this member AC and CB or BC. So we will find the forces. First of all, we have to draw a free body diagram like that, and the free body diagram will show the forces by or reaction by lines and arrows, and the members by lines. Okay, now first of all we have to find the angles between these members. So how can we find these angles? So it is very easy. So if this length I require this length and this length, so it can easily find. So I know that tangent theta equal to rise or perpendicular rise divided by fall. This is rise and this is fall. So theta will become equal to tangent inverse. Okay, and now rise is 5 meter divided by 12 meter. Theta will become equal to 22.6. So I write it already 22.6 degree. This is 22.6 degree and this is completely perpendicular to each other, so it will become 90 degree. So in a triangle there are 180 degree, so 22 plus 90 degree, it will be negative minus 180 degree. So I will find this angle. So this theta will become let's say it is alpha, so it will become 180 degree minus this angle which is 90 degree and minus this angle 22.6. so it will become alpha will become equal to 67.4. okay, and if we find these angles, then we find the force and we convert this force into Newton, because these all measurements and the lengths are given in the SI unit, so it should be converted into the SI unit into Newton. So it is in, for this is weight, force, if I convert it into the force, so it will, F is equal to mg. We know that mass into gravity. Okay, so mass is 100 kg multiplied by 9.81, which is equal to gravity, 1 gravity. So it will become equal to, F is equal to 9.981. Now the force is exerted by this weight is 981 Newton. Okay, so we find that force and also find the angles. In the next step, the first step you have to find angles, and the second step you have to find the convert the weights or any other units to its unit, same unit, or to the force. Okay, this is the second step. And the third step is you have to find this reaction force and this force. There is a support and there is also a support. If the weight is exerted by this the force is exerted by this weight, so the force will be transferred to this member and this member. This member will comes in tension force and this member will come in compression force. So this tension force exert force on this support. So the support exert the reaction force which is in opposite direction. Okay, so the reaction force will be in opposite direction. We have to find this reaction force. Okay, so the reaction force will be finding by the summation of all forces, because this is equilibrium. So we have three equation of equilibrium. So this is in equilibrium state. We have to apply the equation of equilibrium. There are three equation of equilibrium: summation of all moment at a point equal to 0, summation of all moment, all vertical forces and all horizontal forces at a point equal to 0. So no summation of moment, I take this point, which is summation of all moment at point A equal to 0. Okay, so if I take this point is moment at this point is 0, so this force exerted at 12 the distance of 12 meter. So 12 multiplied by 12 is the moment arm and the force RF. Okay, so moment is equal to RF. So one is this force. The first number force is this, which clockwise moment. So I assume that when a moment is in clockwise, so it is, I take it positive, and if a moment is anti-clockwise, I will take it as negative. Okay, now force, this is 100 kg 981 Newton force is exerting 981, okay, positive 981 multiplied by its moment arm, which is equal to 12 meter. Okay, and the other reaction force, which is FCX, which is not found yet. So FCX is anti-clockwise moment at this point. Okay, so I will take it as negative. Okay, force is FCX, which is not found. FXC or FCX at C point, horizontal forces, multiply by the moment M is 5 meter, so it's 5 meter, and there is no other force which is acting on this point. I will take it, these are four moments equal to 0. So if I find that, I calculate this, simplify that, so FXC will become equal to, this is plus, okay, here is plus, so 981 multiplied by 12, this will become negative. 981 multiplied by 12 divided by this 5, this will also be negative, divided by 5. So this negative cancel with this negative sign, so FCX will become equal to FC at C point, horizontal force, which reaction force, which equal to, this will become equal to, I have find it I calculate it already, so 23.54, 23.54, okay, 2354 Newton. The reaction exert at C point will 2354. So I will find this force at this point. This is also reaction force which is exerted by this weight. Okay, so now I will take summation of all vertical forces equal to 0. Okay, or summation of all horizontal forces, I take summation of all horizontal forces equal to 0, Fx equal to 0. So I take, when the force directed upward, I will take it positive. If the force directed downward, I will take it negative. Now there is one force, only one force which is directed horizontally, which is equal to 2354, and the other force is FAX. So F I will take, if the force directed toward left, I will take it negative. If the force directed toward right, I will take it positive. So this force is directed toward right, so I will take it positive, FCX, and this force directed toward left, negative, FAX equal to 0. Only these two forces. Now we can I know the value of FCX, so FAX will become equal to, this is negative, and if I convert to the left side, so FCX, okay, this negative sign will cancel out with this negative sign, and FAX will become equal to, FCX value is 2354 Newton, the same value as FCX, okay. FAX have the same value as in FCX, okay. Now we have found these forces. After that we will find the forces in this member and in this member, which is required in our question, okay, which is exerted by this whole weight, which is 100 kgs. How can I find it? So I will find it by joints method, okay. Now I will take joint CB. You can take this joint, but there is two unknown forces. You can also take this joint, but I will take this joint, okay. So it can be easy because there is a weight and these two members are unknown. So if I take this joint, I will first draw a diagram of this joint. This is my weight, which is 981 Newton, okay, and this is my BC member, okay, BC, which is directed upward, and this is my AB member, okay. Now I will, first of all, I will by head to tail rule, I will convert to it its component, resolve to its component. So this force will have two components. One is horizontal component, which is directed toward right, and a vertical component. Horizontal component will F force in horizontal component, which is BC cos this angle. We have found that this angle is 22.6 degree, okay. So cos 22.6 degree, okay, and this component will have FBC sine 22.6 degree, okay. I have also, so this will become very easy now. So in the members, you notice that and keep it in mind, in the members there will be no movement, only there will be two forces. One is horizontal force and the other is vertical force. So there will be no moments. So I take summation of all vertical forces Fy equal to 0. So if I take all vertical forces, one vertical force is 981, so 981, okay, which is downward. I take it negative. and the other vertical force is FBC sine 26 point, so it is upward, plus FBC 26 point cos, sine 22.6 degree, okay, equal to 0. There is no other vertical force. So 981, FBC equal to 9 plus 981 into divided by 981 divided by sine 22.6 degree. Okay, if you calculate this on your calculator, it will become equal to, I have already calculated that, 2550 Newton. Okay, this is my FBC. Now I will take summation of all vertical forces at joint B equal to 0. F all horizontal forces equal to 0. So there is how many horizontal forces are there? One is FBC cos 45 and the other is this AB. So plus FAB plus FBC cos 22.6 degree equal to 0. So FAB will become equal to negative, FBC value is 2550 Newton multiplied by cos 22.6 degree. Okay, so FAB will become equal to negative 23. So if you calculate it, negative 2350 Newton. Okay, the force in this member, AB is 2350 Newton and the force in this member is 2550 Newton. Okay, we have found all these forces in the member. So there will be no force exert, okay, because this is between the two supports. You don't have to find this force. Okay, there is no force exert in this member. Okay, thank you very much.